Section 5.1 Proving Identities. This section, we are going to use the basic identities to prove other identities. Recall the set of the identities we saw before. From chapter 1, the basic identities in the reciprocal group would be the cosecant of theta is the reciprocal of the sine of theta. Secant theta is the reciprocal of the cosine theta. The cotangent theta is the reciprocal of the tangent theta. Where the other way around, the sine theta is the reciprocal of the cosecant theta and so forth. Another group is the racial identity. The racial identity would be the function, the tangent theta in the ratio of the sine and the cosine of theta. The cotangent theta, which is the reciprocal of the tangent in the ratio identity form, gonna be the cosine theta divided by sine theta. Another group is the group of the Pythagorean identities from cosine theta squared plus sine theta squared equals 1, and then rearrange it by solving for sine squared theta to obtain 1 minus cosine squared theta. And then if we take the square root both sides, the right hand side will become plus minus square root of 1 minus cosine squared theta, which is the same way that we can do with the cosine squared theta. And the other two Pythagorean identities would be 1 plus tangent squared theta equals secant squared theta. And the last one is 1 plus cotangent squared theta equals cosecant squared theta. The procedure to prove or verify a trigonometric identity, we're going to use the trigonometric substitution and algebraic manipulation to either. Number 1, transform the right side of the identity into the left side. So this case, the left side, we use the notation the right hand side, and the left would be the LSHS, which is the left hand side, or starting from the left hand side to show that it's the same as the expression on the right hand side, one way or the other. Note that the main thing to remember in proving identity is work on each side of identity separately. Do not treat the problem as an equation. So it's not an equation that you have to solve. You just have to show that the left-hand side equals the right or the right equals the left-hand side. So the general guidelines for proving identities, number 1, work on the more complicated side first, and then look for the trick substitution involving the basic identities that may help simplifying things. Next step, look for algebraic operations such as adding fractions, distributive property, or factoring that may simplify the side you are working with, or that will at least lead to an expression that will be easier to simplify. Step number 4, if you cannot think of anything else to do, change everything to sines and cosines and see if that helps. The last one, always keep an eye on the side you are not working with to be sure that you are working toward it. The best guidelines practice. The more identities you prove, the more you will be able to prove and the more confident you will become. The next best guideline, don't be afraid to stop and start over if you don't seem to be getting anywhere. Examples. Number 1, we're going to show that part A, 1 plus tangent square theta equals secant square theta is derived from the Pythagorean identity in the form of cosine square theta plus sine square theta equals 1. We're going to work on writing the Pythagorean identity cosine square theta plus sine square theta equals 1. To obtain this identity, as you see the left-hand side, that's 2 terms. The right-hand side, 1 term. We start with cosine square theta plus sine square theta, which is on the left-hand side from the 2 terms. To make one to be the tangent, another one has to be the number 1. If we look at the cosine square and sine square, to make to be tangent, recall the tangent theta is sine theta over cosine theta. So with this way, we are going to divide all terms by cosine square theta in order to see the tangent term appears in the equation. If we divide one term with the cosine square, we're going to divide all of them by cosine squared. And after that, you can see that cosine squared over cosine squared theta equals 1. Sine squared theta over cosine squared theta, that is the tangent squared theta. 1 over cosine squared. Remember, 1 over cosine theta is the secant of theta. Since you squared, it's going to be secant squared theta on the right-hand side. Now, we are done showing 1 plus tangent square theta equals secant square theta is derived from cosine square theta plus sine square theta equals 1. And we're going to do similar way for part B using the cosine square theta plus sine square theta equals 1 to derive 1 plus cotangent square theta equals cosecant square theta. The left-hand side 2 terms, the right-hand side 1 term. Or you can think this way to obtain the cosecant square theta. Note that the cosecant square theta, or just the basic function, that the cosecant square is 1 over sine theta. If you make the right hand side to be cosecant or the cosecant squared, like by dividing the right hand side by sine square theta, you will get the cosecant square theta. If you divide one term by sine square theta, you have to divide all of them with the same quantity, which is sine square theta. Now we have the right hand side as cosecant square theta. Sine square over sine square theta equals 1. Cosine square theta over sine square theta. Note that cosine over sine, that is the cotangent of theta. We squared, so we have cotangent square theta plus 1 on the left-hand side equals cosecant square theta on the right-hand side. So we are done showing that 1 plus cotangent square theta equals cosecant square theta, derived from the Pythagorean identity cosine square theta plus sine square theta equals 1.